It was the Shift Out benchmark report showed an 82% confidence rate in shift left, but only 4% of teams have achieved that zero CVE depth. And let me clue you, I saw that it was 4%. I was shocked that it was 4%, right? I mean, that number seemed even high to me, right? Talk to me why there is such a large perception gap.
The shift left movement's been happening now for over a decade, or about a decade. People started talking about that and using that term to really represent the evolution of DevSecOps, where you can take security into some automated domain, CI/CD pipelines that scan for things and create lists of vulnerabilities and open Jira tickets. And the idea was that it's a lot easier to fix CVEs and manage your supply chain risk. The gap is between this kind of compute speed for detection and human speed for automation. And today in the AI powered world, we've figured out a way to close the gap on remediation automation so that organizations don't have to have that work be done by their engineers. They can shift it out to our technology and to technology stacks like ours that do it for you. That's the core of it.
You and I both know that one of the most sensible ways is through autonomous remediation. Talk about what does shifting out really change about how vulnerabilities are fixed, especially when concerning base images and application dependencies and the realities that we were just discussing.
You need to pin your dependencies and be very specific about which one upgrades you take or not. When you pin your dependencies, the problem that creates is that you often don't have fixes for CVEs you need to be fixed. Pinning helps me avoid malware propagation, and it immunizes me to some degree from this Shai-Hulud style attack. But I suddenly don't have CVEs being fixed at the rate I need them to.
Yeah.
So that's a conundrum, right? I can prevent Shai-Hulud, but I end up running into this CVE backlog conundrum, and I don't want to fix those CVEs.
Good morning, good afternoon, good evening. Welcome back to the Security Strategist podcast, your roadmap for evolving cybersecurity. I'm Chris Steffen. I'll be your host today. I am the Vice President of Research for Enterprise Management Associates, focusing on information security. EMA is an analyst firm that looks at how companies manage their IT infrastructure from the data center out to the user environment and into the cloud. And I focus, obviously, again, on all things nerdy InfoSec. Today, we're joined by John Amaral, co-founder and CTO at Root.io. In the previous episode, John talked about the shift out approach and how AI is changing vulnerability management. Fantastic episode, by the way, if you haven't caught it before. Today, we're going to talk about a little bit about how shift left isn't really working, and it's backed by data, and how the shift out approach can help cybersecurity vulnerabilities rates bounce back. John, welcome back to the show. Great to have you back. Again, great episode last time. Let's get the audience a little bit up to speed. Talk a little bit about Root.io and actually give an introduction about yourself.
Thanks, Chris. Yeah, happy to be here again. Last one was really fun with Rich. And happy to be around security nerds anytime I can get a chance to do that, as I am one of those. My background, been in cybersecurity for about 25 years and various, startups that I've founded or been part of, and large companies like Cisco, where I was head of product for Cisco Cloud Security, kind of a big business unit, but been trying to help the world fight cybersecurity exploits problems for the good, better part of my working life. At Root, what we do is we try to help organizations solve the software supply chain security problem in a couple of different dimensions. What we talked about last time was really about getting to some rational position where you can solve CVEs for the various reasons you might do that, which are compliance reasons or security risk management reasons, in a way that doesn't overly burden your technical organization, your development organization, but also helps the security practitioners meet their required goals, which might be, hey, I have a 7-day SLA on all my critical vulnerabilities and a 14-day SLA on all my highs. I have a list a mile long and my engineering team can't keep up. How do we do that in a way that doesn't suck up too much engineering time solve it and not expose ourselves to these kind of upgrade risks and security posture risks that happen when you don't have a rational strategy for dealing with all that. And at Root, we're building a system where we can do that powered by AI that gives us the velocity to do that on behalf of our customers for them, help them do that. And we described that last episode, how we do that. But we also took it upon ourselves to go out and actually do some research. We partnered up with some folks to go do really good research by the numbers to actually look at what the people who are trying to solve these problems think about their ability to do so that we can have a foundational basis in understanding the core of the problems. And that's what the report we're going to talk about today does.
Yeah, really cool. I know that report, it was the Shift Out benchmark report, showed an 82% confidence rate in shift left, but only 4% of teams have achieved that zero CVE depth. And let me clue you, I saw that it was 4%. I was shocked that it was 4%, right? I mean, that number
Right.
seemed even high to me, right? Talk to me why there is such a large perception gap. I know it's kind of a head in the sand kind of thing, but talk to me a little bit about that and how did we get to where we are?
Yeah. So the shift left movement's been happening now for over a decade, or about a decade. People started talking about that and using that term to really represent the evolution of DevSecOps, where you can take security into some automated domain, CI/CD pipelines that scan for things and create lists of vulnerabilities and open Jira tickets. And the idea was that it's a lot easier to fix CVEs and manage your supply chain risk if you push that toward the developers, and that sounds really great. Like, the developers are the ones using the open source libraries to build software. Cyber security folks, can measure things, and they do, and have security strategy and risk management in mind, but they don't really have the control to change library A to library A version version +1 to address that risk. And they don't know if they're going to break things. So they don't really have their controls on the steering wheel. They're more of a co-pilot than a pilot when it comes to remediation. So what we did was we built detection, CVE detection and risk detection, or vulnerability detection, I should say, at computer speed, at automation speed, and that's produced bigger and bigger lists of things we have to care about. But remediation has never scaled at compute speed. It scales at human speed when it comes down to fixing things, fixing real things, and largely automation in the fixed domain has not paid off. And that's the gap we see. We've got lots of high-speed detection and lots of lists, and companies have spent a lot of time, even vendors have spent a lot of their energy to develop solutions that help you make that list smaller somewhat and make the organization and prioritization and triage of that list easier. But in the end, that backs up onto engineers' desks, significant amount of time arbitrage is made on, should we fix that? Shouldn't we fix that? Why are we fixing that? There's a lot of decision making and risk arbitrage that happens by default. So organizations often just prioritize do nothing or explain away over actually fixing. And that's the gap. The gap is between this kind of compute speed for detection and human speed for automation. And today in the AI powered world, we've figured out a way to close the gap on remediation automation so that organizations don't have to have that work be done by their engineers. They can shift it out to our technology and to technology stacks like ours that do it for you. That's the core of it.
Yeah, one of the reasons that Root does cool things, in my opinion, is it addresses a core problem that is way up on my bucket list. And so give me a second why I describe it. We've talked about detection and response and detection and remediation and however you want to define how that's going to be. With automation, we've done the D part well, right? We do pretty good detection, and it isn't perfect, and I'm not trying to claim that it is, and don't flame me. I understand. Thank you. I love you, all you detection people. Okay, I get it, right? But the remediation part, the response part is terrible. And we're bad. We are bad at it. And you kind of just outlined some of those reasons. A lot of the response Some responses are obvious. Some responses are not obvious, and because there is a human in the middle of it, it is very, very difficult to triage the responses and the priority of the responses that you want. Talk to me a little bit about that. What gives way first when organizations find thousands of vulnerabilities and can only address a few? Because you and I both know that that is a huge problem, and really one of the core problems with the whole response remediation plan that you might have.
Yeah. So let's first start by talking about open source, or what I think of as third-party code. It's the code that an organization uses to build their applications that they get from the outside. It's not the code you write, it's the code you use. And really high percentage of all applications that are built today, starting with Linux as the foundation of this and building up to using Python and JavaScript and Java. These libraries are copious, and about 90+% of all software is comes from that open source environment. When you're asking to remediate vulnerabilities in that, most of the job to do is to fix the code you didn't write. Developers don't know this code. So when you ask them, hey, go fix this vulnerability, they don't have many options tangibly, right? I mean,
Yeah.
I know how to patch things. I'm in the patching business. I build patches for open source. Our team's really good at it. I've had big engineering teams, in order of magnitude, thousands that report up under me of people. They don't know how to do this, and they don't care to know how to do this. Engineers want to work on first-party code. They want to build value for the company. They want to build the new thing. They want to use the open source code. They really don't want their hands dirty with understanding it, nor should they or could they. Meaning that's the kind of the big problem with the shift left with the third-party code is it's not owned by the people you're asking to go fix it. Now, upgrades have been a good and useful way to solve it, but we've seen recently with attacks like Shai-Hulud and the like, that those supply chains can be compromised, starting with with an attack chain that looks like social engineering, but getting the credentials for those open source packages in the hands of nefarious actors. And when the answer to remediation has been radically upgrading, right? Like it's upgrade first, then you expose yourself to this really small exploit window where if I get control of one of these high priority or high profile repos, I can inject malware. And in 15 minutes, if I do that in the right window of time, that malware propagates to literally millions of other repos. So that's this upgrade problem, the upgrade strategy, which was an easy button in some ways to get CVEs down, is a real problem practically from a security perspective and from a maintainability perspective, because when you upgrade, if you have to upgrade to large semantic version jumps, then you've got to go vet whether or not that upgrade broke your software. So what I'm talking about is this whole set of conundrum that is at the vertex between security lifecycle management and software lifecycle management. And that's what you're asking engineers to do and make decisions about. Do I upgrade? Will it break my software? I need to solve the CVEs, but if I stay on the version I'm also already using, which I understand works and I trust, I can't keep up with vulnerability management because the solution to the vulnerabilities are in packages I've not used yet, newer versions. So that's a conundrum. And unless you are in the patching business, meaning from an engineering perspective, which very few organizations are, you can't solve it. The equation doesn't solve. So this gap, and then if you're consuming lots of engineering resources to solve that problem, engineers get burnt out. They're working on stuff they don't like, and they're not building the software you pay them to build to drive your business. These are the tangible issues that are faced.
Yeah, I want to talk about that a little bit. You talk about burnout and so on and so forth, and that's real, right? I mean, if you are faced with a list of 5 billion things and you can focus on only 35 number one priorities, right?
Right.
How do you take and address that, right? How do you take and talk about vulnerability remediation and the impacts on the engineering team? Because I think that's something that we're not talking about enough. Because if you go and talk to the tinfoil hats in your organization, I promise you, they're probably cooked. And especially if you start talking and really specifying what is causing them the biggest amount of brain damage, that is one of the things that's way up on that list.
Yeah, it's insidious, and the problem is that it concentrates on your most talented resources.
It does.
Patching and dealing with upgrades and knowing if things are going to break and if you have to fix things in the open source, you can't have novice resources doing that work. AI helps a little bit, but not much, because a lot of this is rooted in long-term knowledge of your software. So what happens is you get on a team of 5 to 8 people, our survey says, like more than one resource, 1.5 resources is allocated toward this kind of debt reduction, this security maintenance debt reduction. A lot of it's firefighting, because when Shai-Hulud came along, or when like some particularly bad exploit comes around, this is the fire, meaning like we have to get this vulnerability out of our system now. And if you have this kind of very high-end resources who really aspire to work on important problems. They don't think this is important. They know it's urgent, but they don't like the work. They're working in someone else's code base. They're fixing things on a short time frame. And these things keep stacking up and stacking up and stacking up. So they've got a steady stream of work they don't like on short time frames with high stakes and the security people breathing down their neck, which means they don't get to work on what they like, and they get pissed off and they're not happy. And when your best resources, your most senior resources are in this cycle, it has a massive trickle down effect in your culture, and satisfaction in the work you're doing. So this is just toil and debt from the perspective of your best engineers.
It is, and I think the part that we aren't really talking about is that you can take and look at this from whatever perspective you want, but if you are the pointy hair boss that is causing these priorities to be constantly inundating this team, you're stressed out on the executive management side. But I don't think that you really understand the toil, and you mentioned it specifically, that it causes to that engineer, that they are working on the keys to the kingdom. It is extremely high stakes. It is extremely high stress. And you're asking them to make basically unilateral decisions that will radically affect the company based on
That's right.
what your priorities are. This isn't a therapy session, but at the same time, I don't think that we talk nearly enough about what the mindset is with some of these changes. And even if the tool costs $1 gazillion, is that tool, do you see the immediate benefit that comes from a tool like that? Because your engineering team, even if it is the smallest incremental difference and shift in that perception, that small incremental shift is massive to the engineering team. It may not be massive to executive management, but to that engineering team, it is critically important.
Yeah, there are a couple of personas at the executive level that we run into when we help companies solve this problem. One is the CISO type, or security leaders, of course. They have the objective to do security management and remediation, and organizations that choose to be better at this, it's high stakes for them, because they're facing either regulatory mandates like FedRAMP or others, that or customers that are driving them to have their security and vulnerability remediation
and
in
I'll
check.
go so far,
So it's
John,
a business problem.
Yeah, I'll go so far to say, John, that the actual regulatory ones are taking a lesser priority than the supply chain and the vendor managed ones and so on and so forth. Just because
that's right.
You've got to be able to get, pay for your service. You got to pay for the check. You got to have payroll for the next thing, right?
That's right. That's right. So on the security leadership side, they've got real business problems to deal with, because if you can't be FedRAMP, you can't sell your software to the government. Yep. And that's just an example, and that happens across the board. And the stakes are higher on supply chain risk because of the recent spate of attacks that have happened and attacked them directly. That has caused massive churn. Shai-Hulud, I know through our customers and prospects, took significant resources to resolve and understand. I mean, like, this is an expensive problem in bigger companies. And the other kind of awful, I guess, dichotomy here is that the more the more serious you are about this kind of stuff, vulnerability management, security risk management, the more expensive the solution gets because you actually try to go solve it. And then you realize you can't. And that's where the transition over into the engineering organization happens. Now, the VPs of engineering are getting a lot of pressure. Security and vulnerability management, open source securities, it becomes a business problem because they know it's connected to these business mandates. It's when security intersection with your business, and more, this is true, is that if I don't do security well, I can actually compromise my ability to sell my products. So then the engineering leaders know that in moderate organizations, we see, if you think about this, if it's 1.5 to 2 engineers, and in really security conscious companies, it's more like approaching 2 engineers per team. When I say team, it's 5 to 8 people. If you've got 10,000 engineers in your organization, this is a multi-million-dollar problem just from the perspective of how much engineering resource you apply to it. And think about the opportunity costs. Those engineers are working on toil to fix these libraries, and they should be working on your best features because they're your most talented engineers. So that dynamic, these engineering leaders know that they're spending a lot of money on this problem, and they're not staying ahead. They're frustrated. So the more important it is to you, the bigger the scale of your problem, because you're trying hard to solve it, and that's kind of a death spiral of sorts.
It is,
I need it badly, and I can't get it done.
No, I hear
really,
you.
Well,
it starts to drive you nuts, right? And so you got to take a look for what a realistic way to eat the elephant, right? I mean, you can't eat the elephant all at once. And you and I both know that one of the most sensible ways is through something that I think that you've talked about before, which is like autonomous remediation, right? Talk to me what that means. Talk about what does shifting out really change about how vulnerabilities are fixed, especially when concerning base images and application dependencies and the realities that we were just discussing.
Yeah, let's talk about it in terms of kind of a real example of what a exploit kill chain looks like. And I'm going to be very high level on this because it's this type of attack that you really need to solve. If you talk about real security risk in open source, this is one of the kind of real security risks. Shai-Hulud attack at a high level was malware inserted into repos, and there was this kind of like worm-like malware that could propagate, and its propagation, meaning like it can propagate by you upgrade, you have the malware now in your libraries, you run those libraries, and those can propagate. And it starts with a maintainer, a well-intended maintainer who perhaps was compromised by social engineering, where they gave up their credentials somehow, and then a nefarious maintainer, kind of a nefarious imposter, goes in, makes a few benign check-ins, starts to kind of do things. Either they do it, I'll say, in an intentionally surreptitious way, where they're going to sneak something in as fast as they can right before the update window, or they become a maintainer. They pretend like they're good for a while, and this is a longer term kind of social engineering problem. And then they suddenly do a malicious check-in. This is very common now, and is becoming weaponized by a nation state and highly organized actors. Okay, so this means that one check-in to one repo that's highly consumed, say in the NPM ecosystem, can be instantly propagated to millions of other repos or other commercial code bases, and suddenly starts to propagate from there. This is bad, right? And this is a real modern supply chain attack, highly successful attack recently. And these things can do all sorts of bad stuff once they're running. Well, what you need to do, let's first talk about the propagation vector, right? The propagation vector here is that the consumers of that repo that was hijacked are doing automatic upgrades. Why are they doing automatic upgrades? Because they want security fixes fast, because they want CVEs to be low. But this trust on first use problem with this automated upgrades means that when your CI/CD pipeline kicks off, it takes that, it looks at the semantic difference or does some heuristics on whether I should use that upgrade, and it decides yes, and suddenly you've got this propagation problem. So to solve that, what do you need to do? You need to pin your dependencies and be very specific about which upgrades you take or not. When you pin your dependencies, The problem that creates is that you often don't have fixes for CVEs you need to be fixed, right? Because I was hoping those CVE fixes would come in the form of the upgrade from the maintainer because they do security maintenance. So pinning helps me avoid malware propagation, and it immunizes me to some degree from this Shai-Hulud style attack. But I suddenly don't have CVEs being fixed at the rate I need them to.
Yeah.
So that's a conundrum, right? I can prevent Shai-Hulud, but I end up running into this CVE backlog conundrum, and I don't want to fix those CVEs. So to me, automation looks like the following recipe. Automation allows me to pin my dependencies in a way that I can understand and consciously pick which upgrades I use or do not. And the picking of those comes from my understanding of risk for those dependencies. And two, automation includes automated patching for pinned releases so that whether or not the maintainer decides to backport fixes, the automation does it for you. And these are the two things Root does for you in the solution we described last time. This is what shift out means, that I can find a source like a company like Root who can provide me pinned versions of releases that I use, vets them for security so I know when to upgrade, and backports fixes or creates patches for all of the CVEs that I have to fix within my SLA window. If we can automate those actions, then we can have total control over our dependencies and immunize ourselves from maintenance of the risks I described with Shai-Hulud.
Yeah. No, that's very cool. I know that we're running out of time, and give me about 60 seconds worth of a takeaway. If there's anything that you think that somebody listening to this podcast should be thinking about vulnerability management in 2026, talk to me about what that one takeaway would be.
That I think the shift left style, scan, inventory, and triage lists is a dying and kind of diminishing value way to approach it. You need to have a cogent strategy for managing dependencies. Most organizations don't pin their dependencies. You should investigate how to do that and what it means, and think about how having more precise and proactive control over dependencies can work for you. And you need to take that on in 2026, because Shai-Hulud is just the tip of the iceberg here. It's going to happen over and over again this year. You need to be on top of it.
Yeah, we're not done talking about this for sure. And again, your insights are fantastic. I really appreciate you joining me on the podcast today. Thank you to all the listeners out there. We hope that you took a lot away from the podcast. For further information on what we talked about, head on over to root.io. Great information there as well. We'll be back next week with another episode in our podcast series. Until then, make certain you subscribe to this podcast on all your major platforms and follow the conversation on our socials, EM360 Tech on X, Twitter, whatever they call themselves today, and LinkedIn. And for more great daily content, head over to em360tech.com. John, again, thanks for joining us, and thanks for everybody for listening.